Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. The man behind your cat videos, how quantum physics runs your world. You ever hear about a scientist who changed the world just by making electrons jump? Sounds like a Marvel origin story. It's not. This is Niels Bohr. No cape. No superpowers, just ideas sharp enough to slice reality open. And today, we're stepping into his world. Relax. No scary equations. No textbook nightmares. Because Bohr wasn't just building theory. He was turning the invisible into something you could almost feel. Think about the phone in your hand. The one streaming cat videos at 2 a.m. That little device, it runs on rules born in the quantum world. And Bohr helped write those rules. He took something people couldn't even picture and made it just clear enough to say, oh, so that's how it works. Like they say, the devil is in the details. Bohr went looking for the devil and found a universe. He didn't just study physics. He changed how reality behaves in our understanding. And here's the wild part: his story doesn't start in some futuristic lab. It starts at the dinner table. Because the Bohr family, they weren't exactly normal. His father, Christian Bohr, was the kind of guy who could turn breathing into math. Not metaphorically, literally. Imagine asking, "Can I have dessert?" and getting, "Sure. But first, let's calculate your oxygen intake per breath." That was dinner. Fork in one hand, equations in the other. Most kids here, finish your vegetables. Bohr heard, let's model respiration with variables. At some point, you just know, the kid is either going to rebel or become very, very interesting. Bohr chose the second option, but with a twist. Because instead of following his father into physiology, he looked somewhere stranger, smaller, weirder. The invisible world. Atoms, electrons, energy. The stuff you can't see, but can't escape either. While his father was busy explaining life, Bohr was quietly asking, what holds everything together? And more importantly, why does it behave so strangely? Now, most students dream big. Black holes, galaxies, the edge of the universe. Bohr, he zoomed in, way in. He wasn't chasing the biggest questions. He was chasing the smallest ones. Because sometimes, big doors swing on small hinges. At the University of Copenhagen, he started digging into a brand new field, quantum theory. Back then, it was chaos, half ideas, half confusion. Most people avoided it. Bohr walked straight in. Not because he had all the answers, but because he had better questions. He wasn't memorizing formulas. He was interrogating reality. Why do electrons behave like they have a mind of their own? Why do they refuse to follow the rules? Why does the universe, at its smallest scale, act like it's improvising? Bohr didn't accept that's just how it is. He kept pushing, kept poking, kept asking, what if we're thinking about this all wrong? And then he flipped the table. Before Bohr, atoms were simple, too simple. Picture a tiny solar system, electrons orbiting the nucleus like planets around the sun. Neat, clean, wrong. Because according to classical physics, those electrons should spiral inward. Crash, game over. But atoms don't collapse, matter exists. So something wasn't adding up. Bohr stepped in and said, maybe electrons don't move the way we think. Not smoothly, not continuously, but in jumps. Discrete, precise, almost like stepping stones. He introduced a radical idea. Electrons don't just orbit, they occupy specific energy levels. No in between. No cheating. You're either on the step, or you're not in the staircase at all. Like a dance floor with strict rules. You can dance, but only on marked spots. Try something fancy in between, you're out. And when an electron jumps from one level to another, it releases energy. A flash. A signal. That's why atoms don't glow randomly, they glow in patterns. Lines of frequencies, signatures. Bohr didn't just describe it. He explained it. Suddenly, the strange spectral lines of hydrogen made sense. Not magic, not mystery. Just rules we hadn't understood yet. He took Max Planck's idea that energy comes in chunks, and gave it a home inside the atom. That's the moment things changed. Because once you accept that nature works in jumps, you're not in classical physics anymore. You're in the quantum world. And in that world, common sense is optional. Bohr became something rare, a translator between a universe that speaks in riddles and humans who demand logic. He didn't make things simple, he made them understandable. There's a difference, and that difference built modern technology. From semiconductors to lasers to the device lighting up your face right now. Bohr never built a smartphone, but without his ideas, you wouldn't have one. Not even close. He turned confusion into structure, chaos into rules, and gave us a map of the invisible. So next time your screen lights up, remember, somewhere in that glow an electron just made a jump, and a quiet physicist from Denmark is still pulling the strings. Here's the thing. Quantum mechanics, it was never a one-man show, not even for Niels Bohr. Sure, he had the ideas, but he also built something bigger. A movement. A place where the weirdest physics on Earth started to make sense. Welcome to the Copenhagen Circle. Not a club, more like a pressure cooker for genius. Young physicists showed up confused and left questioning reality itself. And at the center of it all, Bohr. Not just solving problems, rewriting how you're allowed to think. Because Bohr didn't just ask, what is light? He asked something more dangerous. What does it mean to observe it? And that question led to one of his boldest ideas. Complementarity. Sounds fancy. It's actually a mind bender. Bohr said something that made physicists pause mid-sip. Light is a wave and a particle at the same time. Yeah, take a second. It's like saying your cat is both asleep and sprinting across the room. Doesn't make sense, right? But in the quantum world, truth is stranger than fiction. Light doesn't pick a side. It behaves like a wave when you measure it like a wave. It behaves like a particle when you measure it like a particle. So what is it really? Bohr's answer? That's the wrong question. Because in quantum mechanics, what you see depends on how you look. Observation isn't passive. It's part of the story. You don't just watch reality. You participate in it. Let that sink in. This wasn't just physics anymore. This was philosophy, wearing a lab coat. Bohr was basically saying, reality doesn't come fully packaged, you help shape it. And suddenly, quantum mechanics felt less like a nightmare, and more like a strange, beautiful puzzle. Not fixed, not absolute. Flexible. Context matters. Perspective matters. Kind of like watching a movie. Sit in the front row, it's intense. Sit in the back, it's calm. Same film, different experience. Quantum physics works the same way. And thanks to Bohr, people stopped panicking and started understanding. Well, sort of. Because just when things were getting clearer, enter Albert Einstein. And he was not impressed. Einstein liked order, precision, determinism. A universe that plays by the rules. Bohr. He was okay with chaos, probability, uncertainty. A universe that shrugs and says, let's roll the dice. And that's exactly what triggered one of the greatest intellectual clashes in history. Einstein famously said, God does not play dice. Translation? This randomness thing? I'm not buying it. He believed quantum mechanics was incomplete. That beneath all the uncertainty, there had to be hidden rules. A deeper layer. A cleaner explanation. Bohr fired back calmly, but firmly. No, this is it. Uncertainty isn't a bug. It's the feature. The universe, at its core, doesn't owe you predictability. And just like that, two giants stood on opposite sides of reality. One saying, the world must make sense. The other saying, it does, just not the way you expect. Their debates? Legendary. Not shouting matches, chess games. Thought experiments, counterarguments. Back and forth. Year after year. Einstein would propose clever scenarios to expose flaws. Bohr would dismantle them, piece by piece. Like a calm storm. At conferences. And letters go over long conversations that probably melted brains nearby. And here's the beautiful part. They disagreed deeply, but respected each other completely. Because this wasn't about winning. It was about getting closer to the truth. Iron sharpens iron. and their clash sharpened quantum mechanics. Einstein pushed the theory to its limits. Bohr defended its foundations. Together, they stress-tested reality itself. Bohr's framework, often called the Copenhagen interpretation, embraced uncertainty. You can't know everything at once. Position and momentum, pick one. Precision has a price. And that idea changed everything. Not just physics. How we think. How we define knowledge. How we accept limits. Bohr wasn't just building equations. He was redrawing the boundaries of certainty. And yeah, sometimes he sounded like a philosophical ninja. When Einstein pushed back, Bohr's response was almost playful. You're trying to force the universe to behave. But the universe isn't taking orders. If you want to understand it, you don't control it. You observe it. Carefully. Humbly. Because in the quantum world, certainty is a luxury you don't get. And randomness? That's not ignorance. That's reality. Einstein kept searching for hidden order. Bohr kept saying, maybe there isn't one. And neither man ever fully convinced the other. But that's the point. Because science doesn't grow from agreement. It grows from tension. From questions that refuse to sit still. From minds that won't back down. Their debate didn't end quantum mechanics. It launched it forward. Forced it to mature. To defend itself. To evolve. And today, every time we talk about probability, measurement, observation, we're echoing that debate. Two visions of reality. Still colliding. Still shaping how we see the world. So yeah, Bohr didn't just build a theory. He built a way of thinking. A way to live with uncertainty, without losing your mind. And maybe that's the real lesson. Because sometimes, the universe doesn't give you answers. It gives you possibilities. Let's be honest for a second. When you think about Niels Bohr, you probably picture chalkboards, equations, maybe a very serious guy talking about atoms. But here's the twist. His ideas didn't stay in the lab, they followed you home. Right into your pocket. That phone you're holding, yeah, there's a little bit of Bohr living inside it. Sounds dramatic? Maybe. But think about it. No quantum mechanics, no semiconductors. No semiconductors, no modern electronics. And without electronics? Well, as they say, you can't make bricks without straw. No chips means no apps. No apps means no streaming, and yes, no endless scroll of cat videos keeping you up at 2 a.m. Funny how it all connects, right? Because quantum physics isn't just some abstract theory floating in textbooks. It's baked into everyday life. Every tap, every swipe, every notification, all powered by rules that came out of Bohr's world. Inside your phone, billions of tiny transistors switch on and off like microscopic traffic lights. That only works because we understand how electrons behave inside materials. And that understanding? It traces back to Bohr's atomic model. Before him, atoms were a mystery box. After him, they became something we could actually work with. Control. Design. Build. That's what unlocked the semiconductor revolution. And once the door opened, there was no going back. Processors got faster, memory got smaller, the screens got sharper. Technology didn't just improve, it exploded. And it wasn't just phones. Lasers, medical imaging, even treatments that target diseases with precision, all of it leans on quantum principles. Bohr didn't invent these devices himself, but he laid the foundation. Like pouring concrete before a skyscraper rises. You don't always see it, but without it, nothing stands. And here's something people often overlook. Bohr wasn't just shaping ideas, he was shaping people. At the University of Copenhagen, his institute became a kind of intellectual crossroads. Young physicists arrived with questions. They left with entirely new ways of thinking. Some of them went on to win Nobel Prizes. Others built whole new fields. And Bohr, he guided them not by giving answers, but by pushing them to think deeper. Because as the saying goes, give a man a fish and you feed him for a day. Teach him how to fish. Bohr taught people how to think, how to doubt, how to stay curious. And that's a much bigger gift. Now here's where things get even more interesting. Because Bohr didn't switch this mindset off when he got home. Not even close. Imagine walking into his house on a weekend. You'd expect normal family chatter, right? What's for dinner? How was your day? Not here. At Bohr's place, conversations could drift straight into quantum mechanics. No warning, no warm-up, just straight into the deep end. It was less family dinner, more live science seminar. Picture this. Everyone gathered around, and instead of flipping on the TV, Bohr picks up chalk, starts sketching ideas, explaining how electrons jump between energy levels. Meanwhile, somewhere in the background, someone's probably saying, "Hey, are we still eating tonight?" And Bohr, completely unfazed. Of course. Right after this one last thought. Classic. And the amazing part? His family didn't find it strange. To them, this was normal. Because curiosity lived in that house. It wasn't forced. It was contagious. Even his kids grew up surrounded by it. And they carried it forward. Different paths, different careers, but the same spark. That constant urge to ask, why? It's like what people say, the apple doesn't fall far from the tree. Bohr didn't just build a scientific legacy. He built a culture of thinking, a way of seeing the world. And he had a gift for making the complicated feel human. He'd take these mind-bending quantum ideas and turn them into everyday metaphors. At one point, he compared quantum jumps to suddenly landing in a new spot before anyone notices you moved. Weird image, sure, but you remember it, and that's what mattered. Because science, in his hands, wasn't cold or distant. It was alive, full of humor, full of imagination. And that made people lean in instead of tuning out. Zoom out again. Look at the world we live in today. A world of instant communication, advanced medicine, powerful computing. All of it standing on principles that came out of early quantum theory. Bohr helped turn the invisible into something usable. He took the tiniest building blocks of reality and showed us how to build with them. That's not just science. That's transformation. From a curious student to a pioneer of quantum mechanics, his journey reshaped how we understand the universe. And more importantly, how we use it. Because at the heart of it all wasn't just intelligence. It was curiosity. Relentless, stubborn curiosity. The kind that doesn't settle. The kind that keeps asking questions long after everyone else stops. And that's something worth holding on to. Because no matter how advanced technology gets, it all starts the same way. With someone looking at the unknown and thinking, there's more to this. So next time you unlock your phone, take a second. Behind that glowing screen, electrons are still playing by quantum rules. Still following a path that Bohr helped uncover. And maybe, just maybe, that endless stream of cat videos feels a little more impressive now. Because in Bohr's world, certainty was never the goal. Possibility was. And as they say, the sky's the limit. Unless, of course, you're thinking at the quantum level. The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.